What's up, guys? How are you all doing? Hey, today we're going to be checking out another awesome 3D printer. We're going to be doing a review of the Tevo Little Monster. This thing is not little at all. This thing is massive. It is a huge, huge machine with a build volume height of 19 inches. This guy is insane. If you want to check out the review on this guy and see what the big buzz is about, the Little Monster, then check it out. It's coming up right here, right now on MI Sperry. Alright guys, so this is the completed Tevo Little Monster. This thing is absolutely massive. As you can see, I've got it sitting on a table here, and this thing is humongous. It is actually one of the coolest probably printers to look at, just because it's so big. It prints some huge stuff. So anyway guys, I wanted to just kind of show you a little bit of it as a whole here. This thing was pretty fun to build. It only took us probably, I don't know, maybe 2 or 3 hours to put it together. It was me and my son that put it together. And I don't know, I'd probably say that, maybe 2.5, 3 hours. It actually surprisingly went together very easily. There was only a couple of questions I had, and there was a couple of spots on the cabling that you have to be aware of. Make sure that you get certain connectors put together. There's some that are literally just they don't have like a snap fit connector, and so they just slide together, and those can come apart fairly easily. So I recommend taking and putting a piece of tape around that, okay, so to keep it from doing its thing. As well as I taped up, I'll probably be 3D printing a box for this or something for all the different connectors and all their little frilly things. I just didn't like that jumble mumble flying all over the place. So I'll show you some close-ups of it here in a minute, but basically it goes together quite easy. Like I said, I was able to put it together and my son, and that was the thing I was worried about the most, because I'd seen another YouTuber that had some real problems with getting this thing to print correctly and whatnot, and I have had absolutely no problems. This thing went together very easily. What was nice was these gantries that are right here, these sliders, they actually went together, or they came pre-assembled with the bearings and everything, so they really weren't that hard to get lined up, because I know that you got to make sure the bearings are sized out properly to where there is absolutely no slop in this whatsoever, because if it jiggles or jitters, it can cause your print quality to be off. So that's definitely a pointer tip, but mine came pre-assembled. I didn't have to assemble the bearings or anything, and it was perfectly fine. Now the end stops that are down here, they or at least the carriages for the belts, they actually came disassembled, but it was easy enough to assemble. Really not that hard. It was not complex at all to put these together. The instructions were great. In fact, I'm going to grab the instruction book real quick. Okay, I'm back with the instruction booklet. All right, so they give you this very nice instruction book that tells you exactly, it has full color pages and everything in it, telling you exactly how to assemble this bad boy and everything. And I think it's great. Each individual bag is marked of parts that it comes with, and it refers to those bags and the different instances that you need them. I didn't use any power tools on this. I wanted to see how difficult it really was to put together just with the tools that they provided you, and it was actually fairly simple. It was fairly simple. Now I will recommend something, and like I said, I'll show some close-ups of this, but I do recommend there's some stop tabs that are on these kind of like slider pieces. They're basically just a set screw that goes in here, and that is what is sensed up at the top for figuring out when to stop it from raising up. Now I made sure I took a pair of calipers. In fact, let me grab my calipers. I'll show you. Basically, I had a pair of calipers, and I just used the bottom side of it and made sure that they were all the same height, that they were screwed in the same height. That's really all I did for that, was I just used a pair of these, which you could probably just use a ruler. You know, a ruler would be fine, or find, I don't know, maybe use a piece of plastic and break it off the height that is, and check all of them, make sure they're all the same height. That's really all I did, just to make sure that when they hit the sensor, they're all hitting it at the same time. That's really the only extra special thing that I did. And but yeah, I can't complain. Mine came just fine. A lot of people said the bed on this thing is glass. Now it has a sticker that's stuck over the top of it, kind of like the Wanao does for it's basically kind of a rough hard plastic stickers so that way stuff can stick to it. And trust me, stuff sticks to this very, very well. It is a glass. It has glass underneath it. And some people said that this arrived broken and things like that. Mine was totally fine. There was no broken pieces, nothing I had to worry about. It was fantastic. It has this little head unit, which I kind of like that it's removable. It's kind of cool. You can remove it and look at it if you want to. It's a little touch screen little head unit. Works real fine. It can hook up to a local area network. It can hook up USB. And then one thing that's cool that I will say that is neat, the firmware on this, I think this is a common board that's used. I don't know the name of it or any specifics of it, but I know that it is a common board for 3D printers, is what it uses. But I like having the flash card in it for doing firmware updates. Basically, you shut it off, you pull the flash card out, put the new firmware on the flash card, plug it in, and voila, it's updated and it works. I kind of like that. I think that's a cool feature. So a little micro SD card there. It also has a Wi-Fi module. You can actually hook it to your LAN network via Wi-Fi if you needed to, which is very useful. Now myself, I don't like tethered printing just because Windows loves to reboot your computer when you least expect it. So I really like having the ability to, on the side of this little head unit, it's got both. It's got a USB port where you can load your stuff onto a flash drive, pop it in there and it'll pull the files off the flash drive, or like I have, and it comes with, is a standard, I think it's 16 gig SD card. And this also has all the manuals and everything on it in PDF too, just in case if you want that one manual that I was showing you, the manual right here. If you want this manual, it's on PDF on that pre-done SD card, which is fantastic. So guys, let me go ahead and take the camera off the tripod here, and we will get some close-up shots of this bad boy, and I can show you what it looks like once it's all assembled. And while I'm doing that, I'll show you the assembly video of me and my son, some shots of us putting it together. So check this out, and we'll be back and we'll look at it up close. Okay guys, so here we are up close and personal with it. Here is the extruder head. It's got dual fans on it. It has a single fan for the cooling and regulating the temperature of the head, as you can see. We also have the extruder, which is kind of interesting. I guess I called that wrong. This is the hot end. Here's the extruder. The interesting part about this extruder is, I don't know if you can tell, but it's kind of suspended by basically, it looks like the conveyor cable basically here. It's suspended here, which I noticed some people had some issues with this of not getting it tight. Now I think this is a new addition. They did include some of these little springs, which I don't know if you've seen these on the Wanow and stuff like that. It's basically a tensioner. The spring pulls this tight. Now mine, I don't have mine incredibly tight, but it's tight enough that this doesn't just jiggle all over the place. Because I've seen some people, when, you know, Delta printers can print at high speed, so they can move really quick. And sometimes when this thing is moving like on real short throws, like on real small details, but it's got to fill it in really fast. I've seen other people, this thing just jiggles all over the place, and they get some really bad quality on their build. So what I'm thinking the deal is it's not getting this, they're not getting that tight enough. And so that's where I would want to say, make sure that you get these nice and tight and snug. And then once you do, add these little tensioners that it comes with, and get this where it's, you know, see, I'm poking at it and it's not really twisting or weeble wobbling a whole lot. So that's a main thing to do, is get this nice and secure, because this is a lot of weight and it does weeble wobble all over the place as this thing's printing. So you want to make sure you get that good. The inside, let's see, these are those carriages I was telling you about. I beat the camera against something. The carriages I was telling you about, these, you need to make sure that they're, see, I'm wiggle woggling it around, and just there is absolutely no play in that whatsoever. Make sure that you get these nice and tight. Here is, if I can get in here and show it to you, I don't know if you can see that, maybe I can cup some of the light down to it. This is that pin I was talking about, that make sure these are all the same height all the way around. All of them have it, even the one that's right here, it has it right here as well. Make sure that those are all the same height, so that way when it goes up and then it hits, let's see if I can move the camera up here and be able to see it. When it hits these sensors, you know, I don't know if you can see that. I'll zoom in a little bit. But this basically is an optical switch, is all that is. And when that piece slides up in that optical switch, it knows that it's at the top. Okay, so that's the switch that that those these little things right here go up into. So you got to make sure that that is all the same height and whatnot, so it goes up in the air. The thing works perfectly. Let me push it up. Get it up to the top here. And let me show you underneath here. Here is the underside of it. You have this little BT touch sensor, or whatever they call this, B-touch or whatever. And what it is this basically comes down and it touches the bed. And when it touches the bed, that's how it calibrates. It knows where the bed is and how far off you are and all that stuff, is that little guy right there on the bottom there. Okay, so that thing, if you don't get this plugged in correctly, it will not work, and this will slam into the bed. Okay, so I've had that happen. I had it slam into the bed and just drill itself in. That's one problem that I found, that it's if you get either that sensor connected improperly, or you have problems with it not coming down. It should go down right before it goes down to level. And so the only thing that I've seen that I've had to do previously is when I go to a print, let me get up here, let me turn my light down here. That way we can see this. When I go to a print, I have to go to more and BT touch down. And I don't know if you can see that. Turn my light back on so we get a little more light. But if you can see this sensor is down. Now watch, I'm going to move it back up. I hope you saw that, but this jumps back up. See, so I'm gonna push down and it goes down. I have to make sure that that's down, because if it's not down, it won't, even though I have it in the G code to put that sensor down before it starts auto-calibrating itself, it just doesn't work. I don't know why, it just doesn't work. But it's not too big of a deal. I just manually push it. Now, there could be a firmware update. I could be out of date on firmware, so I will check that. But that was the only thing that was causing this to, right before it would print, it would just slam straight into the bed and just sit there and make all kinds of horrible sounds, because it was trying to push it through the bed because it didn't know that the bed was there yet. So that was the only thing. That's the only caveat I had to do, is just go into, oops, let's turn the light off. Go into the More menu and click BT Touch Down is what I had to do. And then that would set this little sensor, yeah, right here, this little guy, it set him down, so that way when he would come to hit the bed, it would touch the bed and it would know where it was at. And then, yeah, the rest is pretty easy. I'll see if I can let me get some light going, see if I can get up top here and show you the top of it. So it has these big beefy connectors, which I really like. Here's one of the stepper motors. So they sit up top and they just basically pull that gantry system up and down. It has a great big huge power supply. I can't really show you a whole lot of it, being back here in the corner. There's another stepper. And then your your filament sits on a reel right here, and then it goes, at least I pull it down through the center of the machine. As you can see, it is what I usually do. So anyway, so that's the up close and personal view of it. So let's go see how it actually is configured on the computer, shall we, with Repetier host. Okay guys, so now we're going to look at the software portion of this. I got Repetier host all booted up here. I got the latest version. Basically what you do is you just follow that instruction set. I'll give you a shot of it right here, but these instructions actually work really well. They actually take you through all the different steps that are needed to do this. So just go through the instructions. However, I have a few tips to go here. So basically, what I did was, after setting that all up, and they give you, I think they give you a download for some basic settings, but what I'm going to do, guys, is, since I never see this in any forum or any post like that, is I never see the actual the actual code settings, or the settings for the slicer settings, or anything like that. So what I'm going to do is I'm going to export all my settings and give them to you guys. So if you do end up picking up one of these 3D printers, there's a few settings to go on, because I've played around with PLA, I've played around with the ABS, and oh, by the way, this thing prints ABS magically. Normally an open frame design like this, usually ABS doesn't come out very well, but this thing has incredible bed adhesion. It does not warp if you get because the bed can get upwards to 100 degrees C, and it can do it very quickly. It has a nice 120 volt silicone heater. Yes, it powers it off of the 120 volt mains voltage. So it is a very efficient, very hot heater, and so it works really well, because ABS, as we all know, loves to warp. So I'm very proud of that. So let's go ahead and let's grab something. So I'm going to press our add, and I'm going to go down here and grab good old Benchy. Now, once you get this bad boy set up, it is really nice. You can scale things and make it literally massive. So like, we can make this guy like 50, no, not 50, but we'll make him 5 times as big. Yeah, you can make him 5 times as big, and he'll actually fit, and it'll print it that way. I mean, this thing is just super colossal. It's amazing. So I'm going to go ahead and stay with just one. So then we come to our slicer settings, and like right now I've got it set up for PLA, and like I said, I'll export those settings for you guys, and I'll have a link down in the description so you guys can check that out. I'll probably put it on GitHub or something, and you guys can pull the settings off. At least settings that I use and I've had some pretty good success with. I have made a few of them. I made like an ABS fast, I made an ABS with support, and then a regular ABS. Then I've got a NinjaFlex one. That one is being tested. You guys can try it out and see what you think. Have not yet printed it. I just gathered a lot of information about NinjaFlex off of the net, and I'll use that eventually. But this one is like beta. Actually, it's not even beta, it's alpha. Because I haven't printed NinjaFlex with it yet. So I also have a PLA fast with support and regular PLA. Then down here for the extruder, because you have different temperatures, right? So you have your different extruder settings. So I've got ABS, NinjaFlex, and PLA so far as that goes. Now, one thing that I will say that is a helper. Let me hit configuration here real quick. Now I want to show you this. I believe it's in the extruder settings. Basically, I was having some under extrusion and problems happening. Let's see, I believe... let's see, where is it at? I think it was under advanced. Yeah, default extrusion width. I put that to 0. Because that was causing me some issues. With under extrusion and things like that. So filament settings, here we go. Here's the different filaments. So this is for NinjaFlex. Let's go PLA. This is where you'll set up your diameter. Here's your heat. And it gives you a little bit of an offset. Like, it'll be like other layers. So the first layer, you can set up a heat setting, and the other layers, you can set up different, settings and stuff. Found that helpful when doing the ABS. The ABS I did differently. I chose the extruder to be the same, but I did 100 degrees for the first layer, and then 80 degrees after that, because it doesn't need to be blasting that furnace-y hot. But anyway, like I said, I will export all this. Now, one thing that is an interesting deal, I'm going to go ahead and hit slice and let this thing slice it, is the slicing time. Now, the slicing time, or at least
the estimate of time to print is way off, like super far, colossal off. And what it actually is it's actually there's a different place that you need to put your stop and end G codes in. And then from that place, that's where it then calculates the actual start and finish time, because it'll actually estimate the warm-up time of the unit as well. However, you can put an offset in. And so I will show you that here in just a second. Once this gets done slicing, I'll show you that it actually has a pretty accurate time measurement, and I'll show you where to go place your settings to get that time, because I did not know that, could not find it anywhere, and actually I did not find it anywhere. It was just I ran across this setting and I said, I wonder if that's where I need to put it, and I put it in there, and then all of a sudden, voila, the time actually leveled out. So this is going to be kudos for you guys. So we'll pause here for a second and let this finish. Okay, guys, and just like that, it's done processing. So we've got estimated printing time is 1 hour, 3 minutes, 42 seconds. Layer count 240, total lines, ton, filament needed, a whole bunch. All right, so this is a cool thing. What this cool is this visualization. This is actually pretty neat. You can say show single layer or show a layer range. And what's cool about doing this is you can see, layer by layer. It's kind of like in Cura, you can do this, with a layered view. But this is how you can see your different layers, and you can see your infill. You can see how it's gonna put the layers together and all that stuff. It's actually kind of nice. So that's kind of cool. I like to look at that every now and then just to see how the lattice work stuff's gonna set up. But anyway, on to that config. You go up to configure, and I believe it's printer settings. Yes, and it's under scripts. Okay, this is where it tells you the start code and the stop code in the manual of what to type in. Now you have to type that into the slicer settings, but it doesn't tell you about typing it into the Repetier host just printer settings. Okay, if you type that in here, then you will actually get a pretty accurate time. Now, what I suggest is to time your printer, which the printer actually does. It has a time on it, and it'll tell you how long it took it to print once your print is finished. So then you take that time, compare it to this estimated time, and whatever the difference is, that's where you'll come into, let's see, there we go, add to compensating print time. This value right there. Okay, that's what it is, and it's done in a percentage. So what you'll do is based on how far off this is, just ratio it, and get a percentage of how far this is off, and just enter that in here, and it should compensate. And once I added that in, this was like, I think it was like, I don't know, well, whatever 22% would be. So I don't know, another 20 minutes or something. It was an hour, 20 minutes off or something like that. I can't remember. Basically, it took that pretty much out, and it's, within probably a few minutes of the total print time. It's pretty darn accurate now. But the main thing is you have to go to this config printer settings and go to scripts and put your start and your end G codes in that are specific to the Tevo Little Monster printer. And once you do that, then you'll get an accurate. Otherwise, you get this like -8 seconds or something like that. You get this just bizarre estimated time, and no matter how much you add to the compensation here, it ain't gonna change. And it's because it's coming with whatever is defaulted in here for the start and end G codes that comes with Repetier host, and it's just wrong. Let's go ahead and check out some video of it printing, and then we'll come back and I'll show you some of the results from it.
All right, guys, so here's some cool stuff that I have printed. I did go ahead and print Benchy, which came out pretty good. There's still a little bit of gloop-de-gloops on him and whatnot. However, I did print this. This is in ABS. This is actually ABS plastic. And it is actually printed on my fast setting, so I kind of expected the quality to take a hit. There's a little bit of droopage here on the top of that, droopage here, a lot of stringing, but you know, I don't know. It's been my experience that ABS strings quite a bit. But all in all, the hull of the little boat's pretty good. I mean, had a little goopage right there, but not too bad. Actually wasn't too bad for going super fast. I think it was going, I don't know, maybe 200 millimeters per minute or second or whatever that measurement is, and then had it going only 0.2 millimeters height and whatnot. So I thought it came out pretty darn good, considering I was, you know, basically floorboarding the machine to see if I couldn't get it printed super fast. So it actually came out fairly decent little guy. Ones that I thought were pretty cool, these were printed on, I think basically just a normal, let me zoom in here. The layer height is pretty good. This was on 0.1 millimeter, maybe 0.15 actually, millimeters height, as well as then it was kind of on a slower setting for the rest of it, for the infill and whatnot. And as you can see, this is pretty darn flat. I mean, look at that. Here, let me back up. There we go. All right, I mean, it's pretty darn flat. I mean, I was totally impressed. This is ABS, guys. This is ABS. See, I can beat it on the thing and bend it and warp it, and you know, this is ABS, and it did not warp. I was totally blown away by that. And this is with no bed adhesion. Absolutely none. No ABS glue, no glue sticks, no hairspray, nothing at all. Nothing at all. Absolute zero. And this stuck down just fine. I mean, you look at the corners even. Those are nice, sharp corners. Like, they are not warped. Normally you get some warpage on corners, you know, and whatnot. They're nice and flat. I was totally impressed when I printed these out. And what is this? You know, what the heck is that? Well, what it is, this is for my quad. In fact, let me grab my quad. Give me just a second. I got to kind of walk around the room here to grab it. But it's basically going to be propeller shields for my quadricopter. So there it is. So there's my quad that we built a while back. Got a new battery for it and whatnot. But I notice I keep shearing these blades off and it's making me nuts. So I thought, why not put our new great big 3D printer to use. This is basically going to go under the motor, and it's basically, I'm just going to set it on top so you can see. See, this is going to crash into a wall before the blades will. So it kind of gives me a little bit of some rotor protection. See what I mean? It's going to be like that, except I'll mount it underneath. I need to get some longer screws though, because I already have these little lander things that I 3D printed as well. Bolted on, and they're kind of thick, so I need some longer screws. The other screws aren't going to cut it, but I'm going to put this on there, and then that way when I amateurly slam this thing into a wall or something, I got something that's going to, you know, take the hit. And like I said, I wanted to print it in ABS because I know ABS will be flexible enough that it won't just shatter immediately. Maybe it'll take, I don't know, maybe 2 or 3 hits before it'll finally break, you know, but no matter, I'll just 3D print some more. But I was just completely blown away at how that it didn't warp, because something this thin, this small, would just warp like mad. And yeah, I printed 4 of them for all 4 quads, and as you can see, if you look at them stacking them up, I mean, that's a nice sharp edge. I mean, there might be a tad bit of warpage, maybe, I don't know. It doesn't really look that warped. I'm totally impressed. So the printer, that 120 volt silicon heater that's in the bottom of that printer heating up the bed is money. That is awesome. It does a fabulous job with, I mean, like I said, this guy's ABS. And I mean, outside of the I don't know what happened there. We had like, I don't know, it was overhang. So it's got some overhang. There was no support material because I printed him with no support. So it got kind of gooped. But if you look at him, that's a nice flat surface. I mean, that's not warped. I mean, look at the corners. That's usually where you can definitely tell if something warped, is if you look at the corners. And I mean, that is not warped. That's not warped. Now, I mean, maybe a little, need to tidy up some of the retraction maybe, or, you know, definitely slow it down, slow down the speed and get a little finer detail with it. I'll probably print Benchy here again at a slower speed on the kind of like high quality setting that I've kind of come to set up and see what it does. But yeah, that's pretty darn good for being ABS, at least in my experience with ABS. My experience with ABS has been a living nightmare with an open frame 3D printer like these. But this thing seems to, it doesn't bother it at all, which is fantastic. So in any case, so guys, I mean, the thing works really well. Another thing is it prints gigantic stuff. Now let's get some bigger things. Here's a vase that I printed. Now, I printed this in vase mode, so it really probably couldn't hold anything because it's only one layer thick. If you see it, it's very flimsy, but it shows what it can do. And if you look at this, I mean, this is pretty darn good size, and it's nice and all put together properly and everything. There's literally, the quality's great. And you know what? It's crazy about this. You probably could, I mean, I don't know, my camera probably won't show it, but if you look close enough at it, you can actually see where it looks like the pattern kind of changes halfway up. And that's because I took this thing and you can change on the fly on this thing the speed of the printer. And I crank this thing up to 350 millimeters per minute or second or whatever that is, and it just caused a, yeah, you can't really see it. You could tell there was a difference in the design as it was going up, that it was kind of maybe under extruding a little bit, but not bad enough to cause any delamination or anything, but you just tell, it just, the pattern, the swirly pattern changed. But yeah, fantastic print. I mean, that's fantastic looking. And then I don't even think I can get it all on here. Let me zoom all the way out. See, there it is. There's that. I don't know if I can even get this all in frame. But again, I printed in vase mode, so that's why this this actually broke, but I'm still going to show it to you. Da-da! Yeah, it's a humongous rocket. I took a rocket that I saw on Thingiverse and made it, I think it was like 10 times as big or something like that, and it printed this massive rocket. Now, yeah, like I said, I'm printing it in the same mode, so it's literally one layer thick, and my son was playing with it, and the top went, it popped off. So I'm gonna have to probably reprint this. I may print it with the walls a little bit thicker, probably take a lot longer. But yeah, this thing's huge. Like, I mean, look, it's huge. I mean, look, this is a 250 quad. And those of you that are quad guys, you know how big a 250 quad is. I mean, the thing's huge, you know, which is fantastic. And that's where it brought me to thinking, I think I may end up printing a functional wind turbine with this printer, because it's so big. I can get 19-inch blades on this on the deal, because I think the max on that sucker is 19 inches. So absolutely amazing, guys. Absolutely amazing. I am very thrilled and very impressed with this printer, considering it is a kitted printer. Okay. So what I'm going to do now is I'm going to go ahead and stop the camera, and we'll do some final notes and whatnot on the Tevo Little Monster. Okay, guys, so you know, final thoughts on the Tevo Little Monster. I actually really enjoy it. I thought it was an awesome printer. I mean, let me show you to put it in perspective. I mean, here's that rocket. I mean, it prints absolutely massive stuff. Does very good quality. I mean, I have no complaints with the quality on this. In fact, I think the only reasons that I've had bad quality, like with the little shrimpy guy here, Benchy, whatever his name is just settings. I just need to tweak some settings and get it working again. But I mean, massive build volume, great big huge thing. It is impressive to just look at. It's just cool because it's so big. Even one of my kids was like, whoa, when they saw it. It's a lot bigger than the simple desktop ones. And I don't know, it prints great quality. It does really fast, because since it's of a Delta design, it's really quick. So yeah, honestly, in my opinion, I would say if you can spring for it, it's kind of expensive though. With that $7.99 price tag, that's kind of expensive. However, what you get for it though, the huge build volume and the speed of printing, I say give it a try. I say fire it. I think it's worth the money. I really do. Now, only time will tell. I will keep you guys posted, because I'm going to be printing the crud out of stuff with this machine. You know, I even noticed my Halo helmet fits inside of it. It would actually fit in the build volume. Now, the support material would probably be an absolute nightmare. But in theory, you could print the full Halo helmet as one solid piece on this machine. It is that big. So a full-size adult Halo helmet you could print on this machine as one solid chunk, and it would fit. So that might be something I may try to do. I may try to find one that's one solid chunk and try to print it. It's going to be, the support material would be horrible to figure up, but I don't know. We could give it a shot. It ought to be pretty cool nonetheless. At least it ought to make for a very cool failed print. All right, guys, this has gone way too long. I apologize for that, but I wanted to give you everything that I had on this. So, guys, make sure to like, subscribe, share, and all that jazz. Check me out. Please leave some comments down. If you have any questions about this or 3D printing, again, I'm not a master, but I've probably bumbled through it. If you're bumbling through it, definitely ask me a question. Maybe I've stumbled across the same problem. I will totally help you guys out because that's what I'm here for. I enjoy the community here. I love talking to you guys and listening to you guys' comments, so definitely put that down below. Make sure and check me out on all the other social medias, whatnot. I've got new t-shirts are going to be coming on Zazzle.com/misperry, so definitely go by there here and there. I'll probably post on Twitter and Google Plus and all that when I release that. So there'll be some new t-shirts coming. Check out all that other stuff and find me on all the other socials. And with that, guys, that ought to do it. I will see you next time.